Okay, when doing Punnet squares, and spelled like this, Punnet squares, there's a few things we should already know, but we'll cover it right now. A Punnet square looks something like this. It looks like a square. Sorry for the bad square. And it does have at least these four spots within it. And usually we're solving genetic problems where we're trying to figure out what offspring are the kids, what the offsprings are of the kids when you have, let's say, a father here and a mother here. Okay, so give me a second here, and what happens is you have a trait, and a trait could be some characteristic. For example, today, for this example, the trait is going to be height, the height of a plant. Okay, so the trait today is the height of a plant, and to do that, we have to understand that the mom and the dad both have alleles, and alleles look like this. So what we're going to say, big T allele. So this is an allele. Here's one allele right there. See it? That's a capital T, and that means tall. Okay, and lowercase t will be short plants. So when I grow them, plants can be really short plants, or they could be these tall type plants. And there are usually two types of genetics between these. In other words, what we call genotypes. So if you think about all the different combinations, there's only two letters. You could end up having both big T's, or you could have a big T and a little t, or you could have a little t and a little t. That's all the combinations possible. Um, and if if you have two tall alleles, then of course you're going to be tall. That makes sense. If you have a big, sorry, and then we'll go over here, little t, then of course you're going to be short because you have two alleles and they're both the short allele. And this one, when you have two talls, of course you're going to be tall because you have two of the tall alleles. Oops. So you have two of the tall alleles. Now, what happens here if you have one tall one, one short one? It depends. It depends. So in this one, we're going to say it's dominant because in Mendel, when he did peas, the big T was dominant. So we'll say it's tall. Okay? That's a T there. Tall. So this means it's dominant. Okay? So that means that the big T is dominant over the little t. It dominates over it, and the little t has no say in it, and it just becomes a tall plant. There are some times where the two alleles, the big one and the little one, are what's called co-dominant. So maybe this would be a medium plant, or if it was for, let's say, black hair and white hair in a cat, then if you mix them, you might get like gray or something like that, and then that becomes co-dominant. Okay, in other words, they're together. It's not quite fully dominant. It's sort of like a partner with the other one. But this one right here, my example today, will be a dominant one. Okay. Now, one more thing before we do the Punnett square, and you need to know these for the problems, is that when you have parents, so looking at parents, you could have big T, which is, so the parent has these two, and we would call that homozygous, meaning there's two of the same. Homo means same, so same and same, and we would call it homozygous dominant. Oops, that's dominant. So this is equals homozygous dominant. And if you have two little ones, we would say it's homozygous because they're both the same, little and little, homozygous, but we'd call it recessive. Okay, so this would be homozygous recessive, this is homozygous dominant. If the parent had this, which is possible the parent had that, because he got this from his dad, he got this from his mom, or whatever, or vice versa. So he's different, right? They're different, so we would say heterozygous. And we don't say dominant or recessive because you have one of each, so we just call it heterozygous. So if you say it's a heterozygous parent, just know you'll have a big one and a little one, got it? If they say homozygous, make sure you pay attention. Is it homozygous dominant, 2 capitals, or is it homozygous recessive, 2 little? For this example right here, I'm going to do 2 examples. Let's say you have a homozygous dominant parent here, and the mom right here is homozygous recessive. So she's short, he's tall. And what kind of kids is possible? You would have a big T and a little t, a big T and a little t, a big T and a little t on this one, and a big T and a little t on that one. So all of the kids would be tall, okay? Just because according to this graph. Now, what if, and I'm going to do a what if here again, let's change this. What if the 2 parents are heterozygous? So they're both this. Let's say both parents are heterozygous. Let's just change things up a little bit, because it could be any 3 of these. But I'm just going to make both parents heterozygous. What would their kids be like? You would have big T, you have big T, little t, big T, little t, and then little t right here. So 25%, so you would say this, and this is where the worksheet comes in here. You have 2 things. You have the genotype, and this is more words here, genotype. And so you would say, and these are all genotypes, by the way. Here's a genotype, here's a genotype, here's a genotype, here's a genotype. These were 3 genotypes I explained right here. So what are the kids? What are the kids here? We got 1/4, or you could say 25%, whatever you want. One out of 4 is big T, and 2 out of 4 is big T, little t, right? 2 out of 4, this one and this one. And then 1 out of 4 is this one right here. 1 out of 4 is little t. So those are the genotypes possible. 1 out of 4 will be big T. 2 out of 4 will be big T, little t, and 1 out of 4 will be 2 little t's. And then on this side in the worksheet, you'll see that there's phenotype. And phenotype is how they're expressed. What does this look like? So here's the genotype. This is just what the 2 alleles they'll get, all the combinations. But what will these look like? That's the phenotype. So we would say 1 out of 4 will be tall. 2 out of 4 will be tall, because remember big T is dominant, so this becomes tall. And 1 out of 4 will be short. Okay, so this is genotype. It just says what these 2 alleles they get and what's the probability. And then the phenotype is what's the probability and what will it look like. So that's the 2 sides. Genotype is what the genes look like, and phenotype is what does it physically look like because they have those genes. Well, in other words, when the genes are expressed, what do they look like? Okay, so that's pretty much how to do the Punnett Square.